Hi, today I'm going to talk about the work energy principle. The work energy principle states that the change in the total energy of a particle is equal to the work done on the particle. Now, a major consequence of this is that after a conversion from gravitational potential energy to kinetic energy, for example, after a ball has been dropped, that's K. It means that the difference in the energy gives the work done by resistive forces against the motion. What that means is if this ball has a bunch of gravitational potential energy and we drop it and that's converted to kinetic energy, if there are resistive forces in the system, that won't necessarily be the same energy. It won't all be converted because there will be work done against the particle by resistive forces. And we can calculate that by finding the energy difference between gravitational potential and kinetic. This will give us the energy by resistive forces, or the work done. And we know from our physics equations that work done equals force times distance. So if we know the distance traveled over here, then we know the magnitude of the resistive force. To show this, I have the following problem. A box of mass 70 kilograms starts at rest and slides in a straight line down a surface inclined at 20 degrees to the horizontal. After the box has traveled a distance of 60 meters, the surface becomes horizontal and the box slides another further 50 meters before coming to rest. The total resistance due to friction and air resistance is modeled as a force of constant magnitude R newtons, which acts as to oppose the direction of the motion of the box. Find the value of R. Now, the first step to any mechanics problem is to draw a diagram. So we're going to do that. So it says we initially have a slope of 20 degrees to the horizontal. And you have a particle on it. And it goes down 60 meters before flattening off, where the particle travels another 50 meters. Now, on most diagrams, we like to draw forces, but given that this is an energy related question, it's not necessary. So we're only going to be drawing on the resistive force, which acts in this direction as R. Now, as we said before, if we want to find out the value of this, we want to find out the complete gravitational potential energy of this particle first. And we do that using the equation EGP equals mg delta H. We know that the mass of the particle is 70 kilograms, which gives us 70g delta H. So we want to find this because that will be our change in height. It travels 60 meters along the hypotenuse, but our change in height is given vertically. So for that, we need to use trigonometry. We can use SOHCAHTOA. And if we look here, we have the hypotenuse, and we're trying to find out the opposite because the angle is over here. So we will use sine. And so we write sine of 20 equals delta H over 60. So delta H equals 60 sine 20. Now, plugging that in over here, we can get that, let me just write this over here, EGP equals 70g multiplied by 60 sine 20. Well, let's get rid of this. Now, we know that the work done against friction is force times distance. So right now, we're just going to look at this 60-meter stretch over here. Initially, all the particle's energy is gravitational potential given by this sum here. And when it gets down, all of that energy has been converted into either kinetic energy or work done against friction. We know that the work done against friction as it travels 60 meters will equal to 60 R, because the size of our frictional force is R. So that means this gravitational potential energy is equal to the sum of the kinetic energy and the work done against the particle by the work energy principle. Because all the energy over here is gravitational potential, and here it's all kinetic and work done against friction. So we have this equation over here. And we know that when the particle's at this point, all of its energy that it possesses is kinetic. And when it gets to the end of the 50 meters, it has no energy, it comes to rest, or it has no kinetic energy. That means all of that kinetic energy is converted into thermal energy as work done by resistive forces, which means our kinetic energy is completely converted into work done against a resistive force. And as we travel 50 meters, and we know the resistive forces are, we can deduce that EK is equal to 50R. So now we come up with 70G.60 sine 20 equals 50R plus 60R, which is equal to 110R. Now, one final step to get R is we take this whole sum and divide by R. So 70G multiplied by 60 sine 20, all divided by 110 equals R. And that gives us a value of approximately R equals 127.9 newtons. But looking at the significant figures given in the question, we round that up to 128 newtons. So there's an example of the work energy principle in action.